Welcome back and assalamu alaikum, boys and girls. Hopefully, you are fine, and I'm continuing with the question number 3 of the paper 9701/22 October November 2022 for AS level chemistry. I discussed the previous question 1 and 2 in my previous videos. Hopefully, you watched that video. If not, then please go to these videos to watch how I'm going to solve the question 1 and question 2 in those videos. So right now I'm proceeding with question number 3. Remember, we discussed this question 1 and question 2 in the previous videos. Okay, so right now I'm proceeding with question number 3. Okay, here is the question number 3, which look like it is from organic chemistry. So we discussed little part of the organic in question 1 as well. Question 3 says that organic compounds can be distinguished using chemical tests and analytical techniques. Table 3.1 shows 4 pairs of organic compounds. So this is table 3.1, and first of all, if I just read this, A1 is aldehyde, whereas the A2 is ketone. In B1, this is ketone, B2 is also a ketone, and C1 is ketone as well, whereas C2 is an ester. The D1 is tertiary alcohol, and D2 is primary alcohol as well as an alkene. So keeping this, and as I advised, first of all read the instructions, and then after reading these instructions, do as directed. Try not to solve by your own. First read the instructions and then try to solve the question. So he says that complete the table. How? Identify a reagent which can distinguish between the compounds in each pair. Second instruction is give the positive result of the chemical test and identify which compound shows this result. So keep these instructions in your mind. Now I'm going to solve the question. So first of all, we are going to mention the reagent, and then we have to give the positive result, whatever A or A2 is going to show with that reagent. So as I discussed earlier, this is aldehyde, whereas this is ketone. How to distinguish aldehyde and ketone? We can use Tollens reagent. If we use the Tollens reagent, then what happens? We will see silver mirror formed. We will see silver mirror with A1. Okay, and now if I am not going to use this Tollens reagent, I have another reagent as well, which is filling solution. This will also give a positive result with A1 aldehyde. What it is? We will see brick red precipitate. Or even you can say red precipitate. Brick red precipitate, but try not to write just PPT. Write completely precipitate with A1. Furthermore, if you forgot these two, then you also easily mention that the aldehyde can be oxidized but ketone not. So you can use any oxidizing agent. And you know potassium dichromate, potassium manganate 7 are the good oxidizing agent, and whatever the oxidizing agent you are using, then you have to mention that aldehyde will oxidize. If you use potassium dichromate, you can see the change in color from orange to green with A1. And if you are using potassium manganate 7, then you have to say the purple color decolorizes with A1. Hopefully you understand. In B1 you can see it is ketone. This is ketone, and B2 is also ketone. But the only difference with these two, that this ketone has a part called as CH3CO group. This is called as CH3CO group, but that group is absent in B2. To identify this type of the group, we are going to use aqueous alkaline iodine. Aqueous alkaline iodine. Okay, so we are going to take alkali aqueous and iodine aqueous. This is called as aqueous alkaline iodine, and it will only react with the CH3CO group and giving yellow precipitate, so only B1 has the same part, so we can say yellow precipitate formed with B1, not with B2. Okay, so again proceeding, in C1 and C2 you can see this is ketone whereas this is an ester. So how to distinguish? Simply add 2,4-DNPH, and even you can write the complete name, DNPH, 2,4-dinitrophenylhydrazine. This will react with the carbonyl groups giving orange precipitate formed with C1 but not with C2. Okay, next D1 is tertiary alcohol, whereas D2 is primary alcohol as well as contains double bond alkene. So to distinguish alkene and non-saturated and unsaturated hydrocarbon with simple technique, we can use bromine, aqueous bromine. Add aqueous bromine. So we then can say the brown color or orange color decolorizes. Orange color decolorizes. With D2. And if you are not going to write this one, you may use any oxidizing agent, but remember, try to use the potassium dichromate typically. Okay, potassium dichromate, because if you use potassium manganate, then this double bond will also react. Okay, so anyhow, D2 will decolorize the color of change the color of potassium dichromate from orange to green with D2, but not with D1, because this is tertiary alcohol and tertiary alcohols will not oxidize any further. So keep that in mind. This part is complete now. Very solid 8 marks. Okay, then in second part of the same question, he says A1 and A2 are structural isomers. Define structural isomer. Very simple. Same molecule with the same molecular formula. Molecule with, or compound even you can say, with same molecular formula but different arrangement of atoms, or different structural formula, or different displayed formula. So there is variety. Okay, you may write any appropriate word. Different but different structure, or structural formula, or displayed formula, whatever you can see and you can write easily. Next, in third, he says give the systematic name of B2. So we have to proceed back to see where is B2. This is B2, and we can say it is ketone. How many carbon atoms are there? 1, 2, 3, 4, 5. As this ketone group is exactly at carbon 3, either I'm going to assign numbering from right hand side or from left hand side, so it still stays at carbon number 3. So we can say it is pentane 3 1 or 3 pentanone. both are correct. Okay, either I'm going to say it is 3-pentanone, or even I can say pentane 3. 3 is the position of the carbonyl group and 1 is the name of carbonyl group in ketones. Okay, then deduce the molecular formula of D1. So again we have to go back and check where is D1. D1, oh, let me check again. Yes, D1. Okay, so what is the, remember this part is butane, this is the butane, but we are going to write the formula, so we have to find that how many carbon atoms are there. This is cyclobutane, so 4 carbons are there, this one is the 5th, so we have 5 carbon atoms total. 2 hydrogens are here, 2 are here, 2 are here, but no hydrogen is at this carbon. 2, 4, 6 and plus 3, 7 plus 1, 8. So we have total 8 hydrogens. Okay, and then how many oxygen we have? Only 1. Okay, so you confirm 2, 4, 6 hydrogen atoms are in the ring, 3 are here, 6 plus 3, 9 plus 1, 10. Yes, I forgot, 2, 4, 6 plus 3, 9 plus 1, 10, not 8, 10. H10, C5 H10 1O. So this should be the molecular formula. C5H10 O. Then he says D2 forms polymer Z when heated gently. Identify the type of the polymer that forms from D2. So D2 is alkene, contains double bond, carbon to carbon double bond, and whenever double bonding compounds are polymerized, double bonded compounds are polymerized, the polymer formed is addition. The polymer form is addition polymer. Next he says draw one repeat unit of Z. So first of all I'm going to write that compound first, CH2 double bond CH and then CH2Br. That was the compound, I think, no sorry, OH, not BR. This was, okay, let me check. What was D2? This was, yes, so this is 1 2 3 4 carbon containing. So this is butene plus 4, at 4th position there is OH as well. So CH2 double bond CH single bond CH2 CH2, and at this position we have OH as well. So when we polymerize, just focus on this double bond. The double bond is broken down, changes into the single bond, and all the other bonds will go to straight up and straight down. Next, same with this. So to one side we have hydrogen, and to the other side we have CH2 CH2 and OH, and these bonds you have to extend like this, and then as is clearly mentioned, just repeat units, so no need to draw brackets. If you draw, it doesn't matter as well. If you draw, it doesn't matter, but no need to write N here. Okay, so just extend it. Next, okay, this look like the IR analytical technique. He says organic compound E contains 3 carbon atoms. So this is the main evidence that compound E has 3 carbon atoms. E react with cold dilute acidified KMnO4, giving a single product. So this will give us little idea that it could be alkene. It could be alkene. Why? Because only alkenes, when oxidized with potassium dichromate, cold and dilute, they give us diols, and this is the same or single product. Then the figure 3.1 shows about E, whereas F is formed, and you can see the mass increased, or we can say, so what happened? F, so this is E, this is for E, and this is for F. So we can see the difference. You always have to focus above 1500, and we can see here this no significant data is given. mean no functional group, specifically carbonyl of acid, ester, ketone. Okay, so there is no C double bond O, there is no alcohol, so is not this one, this E is not any alcohol or not any acid, ester, aldehyde, ketone, so no one, E is not that. So as I said, there is a chance that this is alkene. So the data for alkene is this one. So as I know many of the values in my mind I have, you need to use your data booklet. Okay, so here is the data booklet. Now you can see, as I said, double bond, you have to focus only this value, which is 1500 to 1680. This reflects that E was a compound that contains carbon to carbon double bond. Keep that in mind. Next, if we have a glance on this F spectrum, you can see no value is, or no peak or no signal is in this area. This area reflects the presence of C double bond O of ester, aldehyde, ketone or carboxylic acid, but as no data is here, mean this F is not that compound. Okay, plus this is due to the OH, this is due to the OH of alcohols, so it clearly means the E was alkene. When it reacted with cold dilute KMnO4, the double bond changes into diol, giving this OH group. So let we confirm from the data. You can see the OH bond, if it is for hydroxyl, not for the carboxyl, so the data will give us a signal at 3200 to 3600. Okay, so now going back, you can see the data is, this is 3031, then 32, so the data is 32 to 36. You can see this data reflects that this is alcohol, plain alcohol. Okay, now going back to see what are the instructions. These were just little general discussion. He says that both spectra shows absorption between 28 to 2950 owing to carbon hydrogen, and because all of the organic compounds contain this type of the bond, so we are not typically using this value. Okay, as this is not a proper functional group, so we are specifically for IR using this data to identify the different functional groups. Use the two infrared spectra and the table 3.2 to identify the group present only in E, so we are focusing for E only. So functional group, as I clearly mentioned, this is C double bond O. The reason is that you have to just quote the value of C double bond O. What it was 1500 to 1680. So we can say there is absorption at around 1500 to 1650. Okay, so this could be the reason for mentioning that there is C double bond C. Okay, carbon to carbon double bond. Then he says use the infrared spectra of F to identify the functional group formed when E reacted with cold dilute. As I clearly mentioned, this is OH, hydroxyl or OH, or just write this symbol. Okay, so explanation, the absorption, there is same format you have to follow. There is absorption at around, what was the value? It is approximately 3200 to 3600. Okay, you may mention the unit as well, you can copy from the table. Then he says that the mass spectrum of E shows the molecular ion peak. Remember, molecular ion peak is the peak that shows MR. And M2 peak. M2 peak shows the presence of halogen. The presence of halogen. Approximately equal abundance. So whenever we say that, whenever there is equal abundance, mean there is 1:1, so this indicates the presence of bromine atom. If this ratio is of 3:1, then it shows chlorine. So as it is clearly mentioned, the abundance approximately 1, then we can say it is bromine. So deduce the relative molecular mass of E. Okay, as we know from the start, he says that there are 3 carbon atoms, and as it is alkene, so it should be propene, like this. This is propene. And as it confirmed, there is 1 bromine atom, so we can place 1 bromine atom to any position instantly, as we are just finding the MR. So you can see, even I can straightforward say 120, but remember in mass spectrum there are use of the isotopes, but we are going to write the relative molecular mass, and we are going to use the average atomic mass. So for average, we are considering this is bromine having 79.9 atomic mass. So how many carbon atom we have? 3. How many hydrogen? 2, 3, 4, 5. So there are 5 hydrogen atoms and 1 bromine atom. Keeping this formula in your mind, we have 3 carbons, atomic mass of carbon is 12, 5 hydrogen atom, atomic mass is 1, plus 1 bromine, and the average atomic mass is 79.9. So this will give you, let me calculate what is the answer. Let me calculate. Okay, 3 times 2 plus 5 times 1 plus 79.9 times 1. So the answer is 120.9. 120.9. Hopefully you understand that. Okay. Next he says that use the information in C3C to suggest this structure. As I already calculated, use this technique to find the MR. So straightforward, I'm writing it here. CH2 double bond CH single bond CH2Br. So this is the structure. Okay. Next, then he says complete the equation for the reaction of E. Okay, that is E. So molecular formula we calculated was C3H5Br. So when it calculated, it reacted with KMnO4 cold and dilute. As I said, addition reaction takes place, and we will get C3H5, double bond is broken down, and 2 OH groups are added. OH whole twice we can write. Diol is formed. Okay. Next, C2 can be synthesized using A1. So this is A1, this is C2. We can see this is an ester, and that ester contain 1, 2, 3. So 3 bonded mean propanol, and 1, 2, 3, 3 carbon atom are this side mean propanoic acid and propanol. And here we have E1. This is 1, 2, 3. This is propanol. This is propanol. So how is then situation? It says devise a multi-step synthetic route to form C1 from A1. So we having only one reactant, and we are going to convert this into ester. Remember that esters are formed when alcohol and acids, carboxylic acids, react together. They give esters. Okay. So as the both side we have ethanol and we have propane. We have propanol and we have what we can say propanoic acid. So it means this is the starting material. So first of all we can say reduce the propanol into propanol, as the aldehydes can be reduced using NaHB4. NaBH4. Okay, sorry, NaBH4, not NaHB4. NaBH4, sodium borohydride. Okay, when we use this, what happened? The aldehyde is changed into what? Propanol. Second, you may write the equation as well, but if you write, it's fine as well. as it's clear, identify relevant reagents and conditions. So as I'm going to write these, so that's why I'm writing in this form. This is the reagent here, this is the reagent, and this was the product. Now oxidize the propanol into propanoic acid by using potassium dichromate acidified K2Cr2O7 aqueous and acidified, so H ions. So this is the reagent condition and this is the product. Finally, for the third step, react the two product with each other. React the two products formed to get propyl, or even to save the space we just say to get what was the name, C2, to get C2 by using H2SO4 concentrated and heat. So hopefully I'm going to repeat first again. Number one, you have to reduce this into propanol, propan-1-ol, this propanol, and then you oxidize this propanol to propanoic acid. Then react the propanol, propan-1-ol and propanoic acid to get this ester propyl propanoate C2. Hopefully you understand, and this is the end of the question number 3. Hopefully you understand properly, and now all of these 3 questions are posted for you, and I'm trying to make the playlist so that you can easily find the related question, and then your paper is complete now. So if you have any questions, student, boys and girls, don't hesitate, ask me as many questions as you can in this comment section, and I will try to keep posting new papers as well. Take care. Allah Hafiz.